Okay. Okay, so let's start. This session will be more about status update, what we did with SBSA Reference Platform in QEMU during last year, because many things happened. So, what is SBSA Reference Platform? Probably most of you know, looking at faces, but I will repeat. It's virtual machine in QEMU called SBSA Ref, because in trusted firmware it's QEMU_SBSA. In EDK2 it's SBSA QEMU, so it's easy to get lost in those names. We try to be as compliant as possible with SystemReady SR, which is server specification, compared to ER, which was mostly spoken at the conference. To the operating system, we provide EFI services and ACPI tables, and it boots most of OSs out of the box because it doesn't boot RHEL with different default EDK2 because they build grab with older EDK2. The problem is known on the Red Hat side. There was some work going on. I got RHEL running on this platform as well, but with some external patch to EDK2. The hardware we have, it's simple. It's SBSA, so SBSA defines that you need to have few components, but nothing fancy in it. We have CPU up to 512 cores, but it needs really a lot of fast cores to run all of them. We have interrupt controller, default version 3. We have SATA controller and USB controller, and both are on system bus, not non-discoverable system bus, because SBSA allows for such things. So we decided let's put it there to show people how to find it on firmware side. Because if we put it on PCI, it's just scan of PCI, it's easy, right? We have CD-ROM and hard drive on SATA bus. We have gigabit Ethernet card on PCI bus. We have the simplest possible graphics card also on PCI bus, and generic SBSA watchdog in case of need, and it is required by specification. Firmware, fully open, trusted firmware, EDK2, nothing to brag about. Everything is upstreamed. If something is not upstreamed, then it is in review on mailing list or Gerrit in case of trusted firmware. And like I said, operating system gets EFI services and ACPI. And what we did last year and this year, during last year basically, from hardware perspective, we moved to Neoverse N1 as default, and after my vacations, after Connect, we will move to N2 by default. So it will be V9 with RME, with RNG, and other interesting feature flags, which we plan to use for interesting things. We got, let me check. Oh yeah, it works. We got Neoverse V1 in QEMU, thanks to everyone. And then Neoverse N2, so we have V9 even, in case of need for things, but turns out RME. At previous Connect, we have had discussions about how to sort out all our queue of patches which waited for time. So after sorting, we got ATS support, which allowed us to make really complex and nasty PCI Express structures. We got rid of legacy VGA card, which was standard PCI. And in QEMU, you can plug PCI card into PCI Express slot, and it is completely fine. But when you start running tests act weird because they get some things which they do not expect. And we got rid of not working USB 2 controller to working USB 3 controller. And it also shown that we did something wrong on firmware side. And we added non-secure EL2 virtual timer, which is present on 8.1 and above as a part of virtual host and extension. On firmware side, we had a lot of work. First of all, we started using platform versioning. It's like for those who use QEMU, maybe you got used that, for example, virt has numbers. There is virt minus 8.1, virt 9.0, etc., etc. This is versioning we don't use because it needs more work on maintain side, and instead of that, we have two fields in a platform configuration which says which version of platform we have. And we use that to say that we bumped that when we added interrupt controller data, then we bumped that when we added ITS support, then again when we switched USB controller, and we used it to check, are we on new enough platform to have USB-free controller? Because if we don't have it, we disable it on firmware side, so any operating system running with newer firmware on old QEMU will still work. We changed how we do communication between layers, because our approach to platform is that we have three layers. We have QEMU on the bottom, which is hardware, only hardware. It doesn't do any firmware-related things. It does hardware, and it provides some data for firmware using our data tree. Then we have, on top of it, we have trusted firmware, which works as kind of embedded controller. It takes data tree from QEMU, from hardware. It parsing it, and then exports to upper layer using SMC calls. There is a specification for it which defines how such things should be done, and we followed that. This allowed us to get rid completely of parsing device tree from EDK2. EDK2 gets device tree from trusted firmware because this is how it works, but doesn't even try to parse it. So we could kill it, but who knows? Maybe someone will want to get, for example, U-boot working on it. So he gets the data. We merged handling QEMU support, QEMU platforms in trusted firmware, because there were separate things, separate files for QEMU virt and QEMU SBSA. And whenever new CPU core was added, we had to enable them for separate platforms. Now we enabled it one place. It works. Less work for us. And we enabled support for all CPU cores which QEMU provides. Of course, SBSA Ref supports less than virt because of reasons. And at some point, we enabled NVMe support because it turned out that, oh, we missed that thing. So platform versioning, yeah, I forgot that I have a slide for it. Platform versioning, it's just to say which version of hardware we have, basically. If we change something in hardware which is not discoverable, because if we add PCI Express card, then platform doesn't change, because this is something we find by scanning PCI bus. But if we, for example, drop USB controller from system bus and put it on PCI, then we need to know that there is no PCI USB controller on system bus anymore, because this is a thing, system bus is a thing which we cannot discover. We need to know what's on system bus. So this is basically how our system works, right? We have hardware. Hardware provides the data tree to trusted firmware. It has a format of device tree, We used device tree library to parse it, but it's not device tree. It looks like subset of it, and we provide only those data which we need, and there is a plan to replace it with firmware handoff protocol once it will get final 1.0 version and start be merged into QEMU and trusted firmware. Then trusted firmware parses data, provides everything by SMC calls to EDK2. EDK2 uses data, initialize the hardware, creates all the ACPI tables, and exports the ACPI tables to operating system. Simple, works according to standards, and so far handles as well. Yeah, I just said. So, the plan is to be SystemReady SR as much as possible. So, with help of some patches which are floating on review on QEMU mailing list, we got to the point where we don't have any failure in either BSA or SBSA ACS. The only things we have skips, like, oh, your CPU doesn't have feature LPA, large patch addressing, which is fine, right? So the test is skipped. So with standard setup, we have 49 of 56 tests pass, which is 87%. When PCI Express card is added behind PCI root port, and PCI root port is basically virtual PCI Express slot, like you have on motherboard, right? When we add PCI Express card, then BSA ACS notice that, oh, there are some serious PCI Express devices, so let's run more tests. So we are at 70 of 82. There are some tests in PCI are done in a way that, oh, you need to tell do you support some flags, and if you tell that you support, then we assume that they are working because there is no way to test it, and then they mark tests as, oh, you passed. So I decided to skip those things. For SBSA ACS, level 3 is 5 of 6. The missing one is large page addressing, which is skipped. For level 4, it's 10 of 12. The thing is, SBSA ACS for those two levels got stripped of many tests. That's why small amounts of them. Most of tests got moved to BSA ACS. Future. Recently, one of the things we did recently was handling NUMA setups. So, because QEMU allows you to have NUMA setup where each NUMA node has own set of CPUs, own memory nodes, and also own PCI Express buses. We have support for CPU in tree. Support for memory nodes is also in a tree. And support for multiple PCI Express buses is in review. It works. You can see. I will present it at demo in 2 hours from now at next floor. We plan to work on CXL support at some point because there were questions from community about it. TPM support is basically on a list because so far no system is requiring TPM, and it requires also work on setup on machine when you run it because you need to tell QEMU do you want software TPM or do you want to pass hardware TPM, etc. And that's why it landed on plans. If there will be real need, we will look into it. Firmware handoff instead of device tree, because firmware handoff is a solution to simplify data which is moved through between firmware layers. It's as simple as possible memory structure. It's like ID, then set of bytes, another ID, set of bytes, nothing else. So like when I looked yesterday at the data tree we pass from QEMU, it will be even simpler than that. System control processor emulation is an entry which may partially replace what we use trusted firmware for, because now we treat trusted firmware as embedded controller. It knows the hardware and it tells firmware bits about hardware. So some parts of it should be done by basically control processor. And during Leonardo talk, I realized that there should be another entry, RME support. But yeah. All code we work is upstream, but we also have project at CodeLinaro. QR code leads to wiki, which we have them, and slides are already there. We have wiki, we have Git repositories there. In one of the repositories is is a copy of EDK2 platforms where we keep a 3-year-old branch with preliminary secure boot support. And for now, we have no time to work on it, but one day we have to go back and get it running. We also have CI job on CodeLinaro, which builds EDK2 for QEMU CI purposes. Questions? Wow, I was quick. Yes.
Thanks for the talk. So you told us there were some aspects of the platform which could not be discovered easily, and that's why you're passing a version number, if I got it right.
Yeah. The SBSA, when it comes to hardware platform components, tells that you can have them as PCI devices, which are scannable, discoverable, or you can also have devices on system bus. And system bus cannot be scanned. So you need to know what devices are there. So QEMU, in our case, we have SATA controller there and USB 3 controller. So we need to know that they are there. So now firmware has hard-coded the data, but if we get rid of one of them, then we bump the firmware, the platform version. Okay, you will be better.
Well, no, I just want to add that you might wonder why the heck did we put those there? And the reason, no. Okay, well, I'll answer that anyway. It's because we found that actually a lot of the partners who built SBSA SR platforms put a few platform devices in. So we wanted to have a few devices so we could make sure DMA and stuff was actually being functional. And
I understood also from Marcin that you wanted to give a mean to test that the discovery was actually happening correctly for the subsequent stages, right? For the software, basically.
Not quite. No. We know which devices we have there, right? We have this thing hard-coded in firmware because this is the only way. But the platform version we keep is, for example, if we decide to get rid of one of the device, your platform will crash when you start touching controller which doesn't exist.
Yeah. Right? So I was wondering, why not enhance the device tree, which is produced by QEMU and passed to TFA, to convey that information, in fact? Because I'm pretty sure you can describe all what you said.
And this is why we're getting rid of device tree, because we keep getting into discussions about how we should change and use more device tree. And what we want to do is we want to emulate what a real server setup looks like. And in that situation, more likely you have an EC or a system controller which you can go and ask, oh, actually, which peripherals do I have on this specific model?
Okay, so it's rather a design decision, let's say.
Yeah.
Okay, thanks.
Anyone else? We still have some time.
Don't be shy.
Yeah, exactly.
Thank you.
Thank you.
Thank you.